Hello Internet, welcome to another tutorial in the series of digital electronics. We'll study multiplexers today. Multiplex means many into one, and a multiplexer is a circuit with many inputs but only one output. Now how do we select that lucky one input that goes to the output is what multiplexer is all about. So multiplexer will select or will steer one of these inputs to the output using select lines. Now it might sound complicated in the beginning for new learners, but multiplexer is a very clever device, and when you understand the logic behind a multiplexer, you'll see its usage and implementation in a lot of real world circuits, bigger circuits. So that being said, I'll talk about the logic diagram of multiplexer first. As I mentioned, it has many inputs. So the task of this multiplexer is to select one of these inputs. I'm discussing a 4:1 multiplexer, by the way. So it has 4 inputs and it wishes to select any of these inputs, and it wishes to forward that input to the output. Now please understand, it does not matter what the input is. For example, if we were to select D0 to be displayed at the output, it would not matter if D0 itself is 0 or a 1. So that's an important point. We are simply concerned about selecting this input and steering it to the output. We are not concerned about the value of the input here. So, and that is being done by these two lines, which are known as select lines, and these are the input lines. Now essentially a multiplexer is a device that has 6 inputs. So if you were to make the VHDL program of this multiplexer, you would define input lines, of course, as input, but the select lines are also an integral portion of the input. So in fact, the intelligent part of the input is the select lines. So output is just 1, and let's see how this multiplexer achieves this target of sending one of the inputs to the output. Now over here I've drawn a basic structure, and I'll start explaining the structure. We'll start designing the structure. Alright, in this logic structure of multiplexer, these red lines, they are the inputs, and all these inputs are connected to the gates, which are AND gates. Now we'll need to manipulate the property of the AND gate, that AND gate will be active for input if and only if other inputs are 1. So this AND gate would forward this D0 line at the output only and only if the other inputs that will connect here are 1. And on the contrary, this AND gate will be inactive if any other input is 0. So these are the key points here which makes multiplexer a very clever device, and it will just select one out of these 4 inputs and will put forward at the output. So let's see how it does that. So if I connect A bar and B bar here like this to gate number 1. Now what will happen is, whenever the select lines are at 0, 0, let's examine what will happen. At 0, 0, A will become 1 and B will also become 1 via these NOT gates. So what's going into the gate number 1 is 1 and a 1 here via the NOT gates, of course. So if you can appreciate the fact that when 0, 0 is applied to this multiplexer from the select lines, only gate number 1 has that combination which will enable this gate in the active state for the input. For example, if I go ahead and make connections for 0, 1. For 0, 1, what I'll do is I'll connect A bar here and B here. For 1, 0, I'll connect A and B bar. And for 1, 1, which is the last possible combination. So each of these combinations, I have chosen the select lines in such a way that only one of the gates will be active. As you can see, while we were discussing the first case for 0, 0, only gate number 1 was active via the NOT gates. All the other gates had one or the other 0 coming in through these select lines combination. Gate number 2 was being made inactive because of this 0 coming directly from B. Gate number 3 was being made inactive from the 0 coming from A. Gate number 4 was being made inactive from zeros coming from both A and B. So this is a very clever combination that only one gate is being active. Similarly, you can check all the other cases. If you check the cases for 1, 1, you'll see and you'll find that only gate number 4 becomes active via direct inputs from A and B. All the other gates will become inactive because some 0 will come as an input via the NOT gate to gate number 1, 2 and 3. So this kind of a combination of inputs along with the select lines will help us forward only one input at this stage. So for 0, 0, D naught will be forwarded here, and 0, 1 will help D1 to be forwarded here, and D2 and D3, and of course Y is the OR gate, which will if if at any point in time only one of the inputs is being selected and rest of them are essentially zero, why being an OR gate will deliver that non-zero input at the output? And that is what we were intending to do. So we know that at any point in time, three of them will be essentially zero. They'll be zero for sure. The other one could be anything. The other one could be a 0 or a 1, but whatever it is, it will be shown at the output. And that is how multiplexer works. It works by connecting your select lines in a manner that only one AND gate is selected at this stage of the multiplexer, thereby forwarding the requisite input at the output. And I hope this tutorial was helpful in clearing the fog and the doubts about multiplexers' basic functioning. And if you liked the content, give it a thumbs up, consider sharing, subscribing, and if you have any doubts, please mention those doubts in the comment section below. I'll see you in the next video. Goodbye.